Hey and welcome. If you've ever wanted to get your hands dirty with data in Python, you are in exactly the right place. Today, we're jumping into Pandas, which is, without a doubt, the #1 tool in any data scientist toolkit. Think of it as the first step to unlocking your own personal data superpower.
So what's Pandas all about? Well, it's designed to take all that structured data, tables from spreadsheets or databases, and make working with it not just easy, but actually intuitive and incredibly fast. It can totally transform data analysis from this tedious chore into a genuine adventure of discovery.
You know the feeling, right? We've all been there. You're staring at a spreadsheet with thousands, maybe millions of rows. It's chugging along, it's about to crash, and trying to ask it any kind of complex question feels like you're wrestling a bear. You just know there are amazing stories hidden in that data, but the tool itself is holding you back.
This right here is the absolute best way to think about the solution. Pandas takes that familiar idea of a spreadsheet, rows and columns, and just supercharges it with the full power of the Python programming language. Suddenly you can handle massive data sets, you can automate all those boring, repetitive tasks, and you can perform complex calculations that would be basically impossible in your standard spreadsheet program.
So how does all this work under the hood? Well, it all starts with one central concept that you are going to use constantly. Let's break down the fundamental building block of Pandas.
And this is it, the data frame. Honestly, this is the heart and soul of Pandas. Don't let the technical name fool you. Anytime you load a CSV file or a table from a database or even an Excel sheet, you're going to put it into a data frame. It's just a table, plain and simple. But it's a table you can command with code.
So what's a data frame really made of? Well, you can think of it like a bunch of columns all stuck together. And each individual column is another key Pandas object called a series. A series is basically just a list of data that has labels. So a data frame, it's just a bunch of these series all standing side by side, sharing the same row labels.
Okay, so you've managed to load your data into a data frame. Now what? What's the very first thing you should always do? Before you can start asking questions, you have to get to know what you're working with. And luckily, Pandas makes this incredibly easy.
You're going to want to commit these 3 commands to memory. Seriously, they are your new best friends. I like to call this the data analyst's handshake. Every single time you get a new dataset, you'll run .head, .info, and .describe. It's a simple ritual that immediately gives you a feel for your data's structure, its content, and any potential problems.
And here's what that first one, .head, does. Think of it like peeking at the first few cards in a deck of cards. It just shows you what's on top of your file. You instantly see the column names, the kind of data that's in each column, and the general layout. It's the fastest way to confirm your data loaded in correctly.
All right, so we've had a quick look. We've done our handshake with the data. Now for the really fun part, asking our data some questions. How do we pull out just the specific pieces of information that we're actually interested in?
Okay, this is a big one. Understanding the difference between .loc and .iloc is crucial, and it trips a lot of people up. But this analogy makes it super simple. Use .loc when you want to select data using its label, like a street name. You're saying, get me the data on customer street. But .iloc uses the integer position, the number. It's like using GPS coordinates. Go to row 0, column 1. See? Both get you to the same place, they just use different ways of navigating.
Filtering is where the magic really begins, and the concept is simple. Just imagine you're using a sieve. You create a rule, a condition, that can only be answered true or false for each row. Then, Pandas uses that list of trues and falses as a sieve to show you only the rows that came up as true.
So, let's make this real. Here's our full little data set of orders. As you can see, we've got all the categories mixed together: home, electronics, and toys. But what if we only care about the electronics sales?
Check this out. This one little line of code creates our sieve. We're creating what's called a mask. And for every single row, it asks, is the value in the category column equal to electronics? If yes, it marks it true. If no, it marks it false. Then we just pass that whole list of trues and falses, our sieve, right back to our data frame. And boom, just like that. Only the rows that were marked true get to pass through. We've instantly filtered our entire dataset down to just the electronics sales. This fundamental pattern is something you will use over and over and over again. Now, filtering is great for looking at individual records, but the real power of data analysis comes from seeing the big picture. We need to go from all these rows to some simple summaries.
To do this, we use a super powerful method called .groupby. And the best way to think about it is like a mailroom. You tell the mail clerk, hey, sort all this data into different cubbies based on the product category. So all the electronics orders go into one cubby, home in another, and toys in a third.
So once the data is sorted into those cubbies, you can then perform a calculation, what we call an aggregation, on each one. For example, you can tell Pandas, okay, for each cubby, just add up the total sales column. It's a simple two-step dance. First you group, then you aggregate.
And the result is incredibly powerful. In just 2 lines of code, we've gone from a big list of individual orders to a high-level business insight. This is so much more scalable and repeatable than creating a pivot table in a spreadsheet, especially when your data gets big. This is really the core of exploratory data analysis.
Now, like any powerful tool, Pandas has a few, let's call them quirks, that can trip you up. So let's cover a couple of the most common mistakes so you can avoid them from day one.
Okay, here are 2 key things to remember. First, if you're trying to change values in your data frame, always use .lock to select the rows and columns. Trust me, this avoids a really confusing warning and makes sure your changes actually stick. Second, when you combine filter conditions, like you want sales in electronics and over $50, you have to use the ampersand for and the pipe symbol for or. The regular Python words and or will not work here, and that's a classic rookie mistake.
So let's just recap the workflow we've learned. You start by inspecting the data to understand it. Then you select and filter down to just the parts you care about. And finally, you group and summarize to find the larger story. Inspect, select, summarize. It's a powerful and repeatable game plan.
You know, we've just scratched the surface today, but you now have the fundamental tools to start your own data explorations. The real power of Pandas isn't in the code itself, but in the questions it lets you ask. So go find a dataset and start exploring. What story is just waiting for you to uncover?